Here we go. This is either a review or a preview of solving equations. As we go through this, notice how my organization is so very clear. I'm showing my steps clearly and I'm trying to be as neat as possible. All of these things will help you get to the correct answer. We're going to go through 3 different equations of varying difficulty. We're going to start with this quite easy first one. Your job is to get x by itself, and you want to get rid of whatever's attached by doing the opposite. So we want to get rid of the minus 5 first, and the opposite of minus 5 is plus 5. So you write the little plus 5 on both sides because you have to treat the left side of the equation the same as the right side. After you add 5 to both sides, you get a 27 on the right, and the negative 5 and 5 add to 0. So now you have 3x equals 27. Your goal is to get x by itself. You want to get rid of the 3. The 3 is attached by multiplication, so you do the opposite of multiplication, which is division. Divide both sides by 3, and you have to do both sides to keep things in balance, and you arrive at your answer. Notice how I'm showing my steps as I go through, and if I wanted to do that without showing the plus 5 and divided by 3, I could also do that. It would look like this. The same idea is happening over here. I just haven't shown those little operations, but I can tell as I went from here to here, I must have added 5, and when I went from here to here, I must have divided by 3. I got an answer of x equals 9, and you're always able to check your answer by plugging in. So I take the original equation that I started with, and since I think x is 9, I replace the x with a 9. Notice how I'm recopying everything in the next step, lining everything up perfectly, and the only change is the x has become a 9. As I go from here to here, only one thing has changed. The 3 times 9 is 27. Notice how everything is still lined up very neat and organized. And when I do this subtraction, I get 22 equals 22. Since I got a true statement at the end, that means my answer was correct. If I would have got something like 22 equals 27, I would have known this answer was wrong, or I messed something up in the check. Okay, our next equation has a fraction in it. We have a divide by 4, and I'm going to show you 2 possible paths. There's probably more than 2 possible paths, but the first path is to get rid of that fraction first, and sometimes they call that clearing the fraction. And the way I do that is I say, how do I get rid of a fraction of 4? And I get rid of that fraction of 4 by multiplying both sides by a 4. Here's what that would look like. Here's my original equation. To get rid of the 4, I multiply the entire right side by 4. And remember, in an equation, anything you do to the right side, you must do to the left side. So when I do that, this 4 has to distribute to both pieces, whereas these two just multiply. And here's what I would get. That's a 32. When I multiply the 4 times the 2, I get the 8. When I multiply the 4 times the x over 4, the 4 in a numerator and the 4 in the denominator cancel. So I've cleared the fraction of 4 by multiplying the entire right side and left side by the 4, and now I have a very simple equation that I can solve. If I didn't want to clear the fraction first, that's fine. Then my steps would look like this. I took my original equation, and I have to get x by itself, which means I need to get rid of the 2 and the 4. I get rid of the 2 first by subtracting 2. I get rid of this 4 by multiplying each side by 4, and no matter which path I take, I still get an answer of 24. I could check it if I want. For our final example, we have a larger equation, and you'll notice that we have variables on the left side and variables on the right side. The very first thing I'm going to do, I don't see any fractions that I have to clear out. I'm going to distribute the 5. Now notice that nothing else has changed. I'm lining up everything else very meticulously like the first step. The only thing that's changed is the distribution of the 5. So now I notice a couple of things. I have two like terms. The 5x and the 2x are like terms. and they're on the same side of the equal sign, so I can combine those two. Notice again that nothing else has changed. Everything else lines up, but a 5x and a 2x, when they're on the same side of the equal sign, just combine like terms. Now is when the variables on both sides really come into play. I have a 7x on the left, a 4x on the right. I can choose to send the 7x over to the other side or the 4x to the left side. It doesn't matter which one you choose, you just have to do it correctly. So I choose to send the 4x over here, and remember this 4x secretly has a positive sign on it, so I do the opposite by subtracting 4x from each side. Notice that the 3 stays, the minus 15 stays, the equal sign stays, everything else stays, but now I just do that move of the 4x to the other side. Now I have a simple equation, and I can solve it using just the regular steps that you're used to. And remember, you could have followed a different path and you'll still get to the correct final answer. And like any equation, if I feel like checking my answer, I can. So I can take the 6 and I go to the original equation and I replace any x with a 6. And if I work through that, I should get a true statement. If I get a true statement, I'm happy. I know that my answer is correct. That is a quick review, preview of solving equations.